In this video, I am going to find the limit of this given function. F of x is equal to x cubed plus 4 over x squared plus 5x plus 2. We kind of want to find the limit as x goes to infinity. Investigate the behavior of this function as x goes to infinity. In order to do so, I kind of need to simplify it. And the way I simplify it is that I look at the highest power of x in the numerator and the highest power of x in the denominator. As it turns out, the highest power of x in the numerator is 3 and in the denominator it is 2. So what I'm going to do, I'm going to take smaller of these two numbers and divide the numerator and the denominator by x squared. If I did that, this is what I get. So f of x is this, divide the numerator by x squared, denominator by x squared. Upon division, x cubed divided by x squared is x, 4 divided by x squared is 4 over x squared. Similarly, in the denominator, x squared divided by x squared is 1, 5x divided by x squared is 5 over x, and 2 divided by x squared is 2 over x squared. So in essence, finding the limit of this function f of x, which is x cubed plus 4 divided by x squared plus 5x plus 2, is equivalent to finding the limit of this function. Now we can apply the quotient rule and rewrite it as limit x approaches infinity, okay, x plus 4 over x squared. Now I'm going to keep a little space here and insert another limit x approaches infinity. So using the quotient rule, I can apply the limit of the numerator, okay? Limit of the numerator and the limit of the denominator. Then again, using the addition rule, I could break down the break down the numerator into limit of x plus limit of 4 over x squared. And similarly, in the denominator, I could break it down to limit x approaches infinity 1 plus limit x approaches infinity 5 over x plus limit x approaches infinity 2 over x squared. Now, let's look at the denominator. Limit x approaches infinity, 1 is just going to be 1 because it doesn't depend on x. So 1 plus limit x approaches infinity, 5 over x has to be 0 because x becomes extremely large compared to 5 and it becomes larger and larger, goes towards infinity. Consequently, the limit becomes 0 because 5 over x becomes extremely small and approaches 0. And with a similar argument, 2 over x squared. As x becomes larger and larger and larger, what happens to 2 over x squared? It becomes smaller and smaller and smaller, and in the limiting case, the value becomes 0. The same argument holds for limit in the numerator, limit x approaches infinity, 4 over x is 0 plus. However, this term, limit x approaches infinity, x is nothing but infinity. So as a result, the ratio approaches infinity. Hence, the limit of this function approaches infinity, becomes infinity as x approaches infinity. So, what to notice here is this. Look at this rational function. Look at the numerator and look at the denominator. The highest power of x in the numerator is 3. Highest power of x in the denominator is 2. So as x goes towards infinity, the highest power of x dominates. Okay? So x cubed term dominates over any other powers of x that are present in this rational expression or rational function. So consequently, highest power of x is in the numerator, so it's going to go towards infinity. I hope that this discussion was helpful. Thank you very much.